Welcome to my channel WinChem. Today we are going to see organic reaction mechanism. It's really very interesting question and very important. Don't miss it watch till the end. And if you are not subscribed to the channel, please subscribe to the channel. It's very useful. Nowadays I'm going to discuss very important questions. Okay, it's not a normal questions. What is the question now? This is the question. In a column 1, all the reactions are there. In a column 2, what type of reactions underwent in these reactions? Okay, whether it is a nucleophilic substitution or nucleophilic substitution or electrophilic substitution, dehydration or nucleophilic addition or carbanion is formed in this reaction or not. That we are going to see in this reactions. Okay. In the first case, if you see that this is the base, if you add a base in this group, so immediately this hydrogen is abstracted by this base. Okay, this hydrogen is abstracted from the methyl group, from the methyl group, the hydrogen is abstracted by the base and it forms a carbanion. So here the carbanion is formed. So that carbanion will immediately attack this carbonyl group and the cyclization takes place. That's why this is happening. And at the end, so here the carbanion will take and it will OH will form, and this OH and this CH2, there will be a removal of water. Dehydration also will take place in this reaction and forms like this. And we will see the reactions very clearly. See the reaction. This is the reaction. This is the pH group. This pH group, if you see here, this pH group, this is the benzene. Okay, instead of this benzene, we have mentioned the area as a pH group. I will mention that as a clearly. Okay, I'll take a pen. I'll write it very clearly so that you understand what is there in that. Here pH group is there. Okay, this pH group is here, it attached to the carbonyl group. Okay, so if you add a base, this will abstract this proton and it will form a carbanion. Okay, this is the carbanion. So if a carbanion form means, so it is T is there in this case. Okay, what is that? T is there. And before that, this is a nucleophile. Okay, nucleophile is adding to this to that. Okay, nucleophile addition is also there here. Okay, so S and T is there. What all is there? S, comma, T. So far we find out these two are is there. Okay. And after attacking this carbanion, this will shift over here. See clearly, this double bond, this double bond will go here and it will form O minus. Once it attacks, then this double bond O minus will form, and after hydration, after addition of water, it becomes OH. Okay, this will become OH. And here one hydrogen is there. Okay, here two hydrogens are there. In that, one hydrogen is taken by the OH. Here two hydrogens are there. Okay, here two hydrogens are there. In that, one will taken by this OH and it will remove the water. So removal of water takes place. So here dehydration takes place. Okay, dehydration is there. So double bond is formed. Okay, this H will come here. So double bond will form here. Okay, double bond will form here. So what is the dehydration? Dehydration is R. So what and all happening here? S, T and R. Three things are happening in this reaction. The same way in the second reaction, if you see that here, its isotopes are there. OH isotopes here, keto groups are there. The same way here also pH we have mentioned here as a benzene. Benzene instead of benzene we have mentioned as a pH. So it's easy. It will not occupy any so much space. That's why I mentioned as pH. So double bond O. Here how many CH2 there is? 3 CH2. 1, 2, 3. 3 CH2 groups are there and OH. Here H2 is over. Acid we are adding. Okay, addition of acid. So the nucleophilic addition takes place this acid. Okay, here directly this OH will go and attack here. So OH plus will form. Okay, here OH plus will form. And then here the lone pair of electrons will attack this carbonyl group and it will satisfy the positive ion. Okay, satisfy the positive ion. See here, OH will come and attack. The cyclization takes place. Okay, cyclization takes place. This O is here. Here the double bond is there. This double bond satisfies this one plus charge, so it becomes OH. This O is there. Okay, this is the OHO. Okay, O is there. So this CH2, two CH2s are there. 1, 2, 2 CH2 groups are also there. 1, 2, 3. Here also 1, 1, 2, 3. 1, 2, 3 CH2 groups are there. Okay, and here the removal of water is taking place and it forms as a double bond. It's not like this. This is a double bond. The same way as we see in the earlier case, the same way here also the double bond will form. Here the carbon, it's a pH group is attached. Okay, here O18, this OH and here hydrogen. Here is also two hydrogens are there. As we saw in the earlier case, in the same way here also two hydrogen is there. The removal of water takes place. Okay, so here double bond is formed as we saw in the earlier case. Dehydration, nucleophilic addition, two things are happening. So dehydration, nucleophilic addition, so R and S. Here R, comma S. And in the third one, what is the reaction? It's a Grignard reaction. What is that? This is the Grignard reaction. If it is say any methyl magnesium bromide, or not even a methyl, magnesium bromide is there, means that is a Grignard reagent. Okay, it's a Grignard reagent. This is a Grignard reaction. In this is the electrophile. This will go and attack in this position. Okay, and this O minus will form. You see here, that's why it's O minus. This is CH3 group. Okay, here C, not CH, this CH3 group, O minus will form. Here this O minus will directly go and attack the CH2 group, and Cl, it cleaves the Cl2. So it takes place simultaneously. O minus attack and that Cl cleavage both takes place simultaneously. That's why it is called as a nucleophilic substitution bimolecular reaction. Okay, nucleophilic substitution bimolecular reaction. So this is you will see very clearly the nucleophilic substitution bimolecular reaction. So electrophilic substitution and the nucleophilic substitution both is there. So we can take clearly this one, nucleophilic substitution reaction. Electrophilic substitution, and second reaction nucleophilic is in P. Okay, Q and P. Both the reactions are taking place. And in the third case, third is over, and in the fourth one, see here, in this place, this is the reaction. Okay, here same way, here also I mentioned this as a pH. In every cases, all the benzene groups I have mentioned as pH, even here also. So don't get confused. So it's easy for you to come to know. And all the CH2 group I have mentioned as a CH2 like line. Okay, CH2, each CH2 is in the terminal, each CH2 is there. And here CH3 is there. Here OH group is attached. In this case, here also H2SO4 is this H2SO4 is a dehydrating agent, as a removal of water will take place. So this is also one of the clue you can come to know. So dehydration is taking place like that. Okay, but in this case, add H plus to that. So here the H plus will go and attack to this. So what will happen? H2 plus will takes place. Okay, so here removal of water will takes place. After that, the removal of water will takes place, and here carbanion will form. Okay, here the carbocation will form. Plus here carbanion. The first case carbanion. Here the carbocation will form, and this carbocation, so frityl graft alkylation takes place. Whether any benzene ring. Here the alkylation is taking place in the benzene ring, means that is frityl graft alkylation. Here the electrophilic substitution takes place. Here electrophilic substitution and electrophilic substitution Q and dehydration R. So Q and R both is taking place. Okay, Q is electrophilic substitution and R is a dehydration. Here the dehydration takes place. So electrophilic substitution and dehydration takes place. This is the reaction. So the answer is given here. Okay, thanks for watching.